So now let us come to another method. First method we have seen how to solve the trigonometric equations by factorization method. That means we will take out the factors which are common. Now in the second method, there are certain trigonometric equations which are reducible to quadratic forms or biquadratic forms or some cubic forms. So we will try to convert them in quadratic or biquadratic forms and then solve. Always remember, whenever solving trigonometric equations, you have to keep two things in mind. First thing is, avoid squaring if possible, because by squaring you are adding some extra roots. Sometimes it may not be possible to avoid squaring, then whatever extra roots have been inserted, that you have to verify and reject them, you have to identify them and neglect them. Second is, if a common factor is there, that is a one root, you are not supposed to cancel it. That we have seen in previous solving questions also. So now in this question number 1, the most important thing in all these questions, whenever you see tan x, cot x, sec x, cosec x, is immediately that somewhere in your mind that idea must come, my solutions must be within the domain, nothing must come outside domain. That means here it will not be defined tan x means sin x upon cos x. If cos x is 0, this will not be defined. So first of all, we can safely assume that cos x is not equal to 0. Because if cos x is equal to 0, this question makes no sense. We will reject all those solutions. So when cos x is not 0, in this second important thing, if you simplify this expression, you will get sin square x into 1 plus tan x is equal to, this expression if you simplify, you will get 3 sin x cos x. This is 3 sin x cos x plus 3 1 minus sin square x, and 1 minus sin square x can be written as, this is 3 sin x cos x plus 3 cos square x. You can write this in this form. So now easily you can see, if I divide by cos square x, everything will be converted. This function is in the form of either sin x cos x is there, or sin square x is there, or cos square x is there. That means in this case, divide both sides by cos square x. So I can convert whole question in the tan x form. So sin square x upon cos square x will become tan square x. So my question will become tan square x into 1 plus tan x is equal to 3 tan x plus 3 cos square x I have divided, so it will be plus 3. So from this can be done as 3 into 1 plus tan x. 1 plus tan x is common. So take that common part outside. 1 plus tan x is common. So what is left here? Tan square x minus 3 is equal to 0. Minus 3, I am transferring these terms to this side. So one solution is tan x is equal to minus 1. And another solution is tan square x is equal to under root 3 whole square. Tan square x is equal to tan square alpha. This, what is the solution here I am using? If tan square x, these three solutions I am writing here, sin square x is equal to sin square alpha, tan square x is equal to tan square alpha, cos square x is equal to cos square alpha. Then this tan square x is equal to tan square alpha. Then x is equal to n pi plus minus alpha. In all the three cases, our answer remains same. So here x will be equal to n pi plus minus pi by 3, 60 degree. X is equal to minus 1, third quadrant, pi plus pi by 4. So x is equal to n pi plus 5 pi by 4. Second quadrant, tan x is negative in second quadrant, pi minus pi by 4, 3 pi by 4. So these are two solutions of this equation. Now let us come to question number 2. Log 10x into 2 plus 4 cos square x is equal to 2. So again here 10x cannot be 0, 10x cannot be negative, 10x cannot be 1. All those things we will see afterward. First we will find the solution, then we will see the domain. So 2 plus 4 cos square x is equal to 10 square x, and 10 square x can be written as sin square x upon cos square x, and then we can put cos square x is equal to t. Quadratic we will convert. Cos square x is equal to t. So we will get 2t plus 4 cos 4. So t square is equal to 1 minus sin square x. Sin square x is how much? 1 minus cos square x, 1 minus t. So this we can simply write as 4t square plus 3t minus 1 is equal to 0. So this gives me that 4t minus 1 into t plus 1 is equal to 0. So if I put the values, 4 cos square x minus 1 into cos square x plus 1 is equal to 0. This can never be 0. So only cos square x is equal to 1 upon 4. So 1 upon 2 whole square, because this cannot be 0. Cos square x is equal to 1 upon 2 whole square. So from here I will get x, cos x is equal to, cos x is equal to 1 upon 2 or minus 1 upon 2. Here is the problem. Cos x is 1 upon 2. In that case also 10x can be negative, and cos x is minus 1 upon 2. In that case also 10x can be positive. So I have to find the exact solutions of these equations. Cos x is half. So in this case cos x is half, and two cases I am taking. Cos x is minus half. Cos x is half. In this case my quadrant can be first quadrant or it can be fourth quadrant. Cos x is equal to minus half. In this case my quadrant can be second quadrant or third quadrant. So if you observe here, in this case third quadrant is allowed, in this case first quadrant allowed, because in first and third 10 will be positive. So here my solution will be x is equal to first quadrant 2n pi plus pi by 1 upon 2. 1 upon 2 means pi by 3. And here my solution will be second quadrant 2n x is equal to 2n pi plus pi minus pi by 3. Third quadrant pi plus pi by 3. So if you observe here both, this is 2n plus 1 into pi plus pi by 3, and this is 2n pi plus pi by 3. So I can merge both solutions, because either it is even multiple of pi or odd multiple of pi. So my answer can be x is equal to n pi plus pi by 3. Both solutions I can merge into single. This is also correct answer, this is also correct answer, and both can be merged into single answer. So this is my answer, this I am rejecting. So this is a very important problem where you have to be very careful of the domain. Question number 3 is sin power 8x plus cos power 8x is equal to 17 upon 32. So here we can use sin power 4x plus cos power 4x is equal to sin square x plus cos square x whole square minus 2 sin square x cos square x. So this will give minus 1 upon 2 sine square 2x. Dividing by 2, multiplying by 2. So it will become 4, 2 sine x cos x whole square. Now this can be written as sine 4x plus cos 4x power whole square minus 2 sine 4x cos 4x. This quantity I have already calculated, that is, so this is how much? This is 17 upon 32. So 17 upon 32 is equal to 2 minus sine square 2x whole square, and when I make this whole square, this will become 4 minus, multiply by 8, divided by 8, 16. 16 I can write 2 sine x cos x power 4. So that is sine power 4x 2x upon 8. I am multiplying this by 8, dividing by 8. This is 2 sine x cos x power 4 is sine this form. So now we can take here, let sine 2x is equal to sine square 2x is equal to t. Sine square 2x is equal to t. Multiply by 32. So 17 is equal to 32 for 8. 8 into 2 minus t whole square. 2 minus t whole square is 4 minus 4t plus t square minus 8 into 4. 4, this will be t square. So this gives me 8t square minus 4t square is 8t square minus 4t square is 4t square minus 32t. 32 minus 17 is 15. So its roots are 2 and 30. So 2t minus 15 into 2t minus 1 is equal to 0. I think this will be the roots 30, 32 and 40 square. These are the roots of this equation. So now you can see this 2t square, that means 2 sine square x can never be 15. So this will not give me any root. What I am doing at 2 sine square x is equal to 15 is not possible, because 2 sine square x maximum value will be 2. So only solution will come from here. 2 sine square 2x 2t is equal to 1 or t is equal to half. 2t is equal to 1. So 2 sine square 2x is equal to 1 or sine square 2x is equal to 1 upon under root 2 whole square. So from here I will get at 2x is equal to n pi plus minus pi by 4. So solution of this will be x is equal to this last equation solution. Answer of this question is x is equal to n pi by 2 plus minus pi by 8. This is the answer of this problem.